Okay, so we have to give some share of the probes, but it's some really cool. If you consider the price you have to pay for a sample of regolith. Okay. So the rover itself, I just skipped this one because all the details will be presented by Michael and Juergen. And some point in regards of the MCU, because Arne shares his part with Jack, and I don't know how long this will take, Jack part, so I'm taking some information beforehand. Our board computing unit is based on an FPGA. If you don't know what an FPGA is, just wait a second and Arne will explain it later. It's a specialized Xilinx Vertex 4 FPGA, which is doing all analog and digital control. It's something means like you have one chip doing all the work, so you don't have 1,000 components around it like you have nowadays on certain mainboards. And this really minimizes the error counter, and you can do a lot of more things that you will see in the last and the following presentation. And this is the important part. Everything of our component is high real certified. High real certified, what does high real mean? Arne will give you an implementation about this. But this means that these components can withstand exposure to space. Just in a brief introduction. Because as I said before, your normal handy or iPhone simply would fall apart. Not just to temperature, but to radiation and vacuum. Okay, one important thing I'm really a fan of is standardized protocols. So what does this mean? If you think about 20 years ago, you've got a rocket here, you got an engine there, and you got some thrusters there, and they all got different wirings, different protocols, control engines, control units, and so on. And you don't have to, let's say, at least order have 50 employees just writing up all the control mechanisms to coordinate all this different equipment. Nowadays, vendors set for standardized protocols, so new rockets and engines have, for example, Ethernet as bus system. It's something pretty cool, so you can use Ethernet in your main control unit to connect it and control the engines and all its thrust and behavior. Okay, and one very interesting thing is we have built a persistent high real data storage, which is something quite special because there's not much where you can store data in space due to radiation. Okay, but I'm just leave this to Arne. Hence this ECC algorithm, I would have liked to talk about this in this presentation, but it really is too complicated, and so I leave it out. But you can talk about, we have a special implementation in this regard, so we can maybe see it in 1 year on Wikipedia or so. Okay, so this almost was it. Just one last slide, and we can go to the rover. The last slide is something for me pretty important because, okay, and just a summarization of our current partners. We have a lot of public and non-public partners. Just naming from one side to one side. We have Texas Instruments. We have CatSoft, which are producing the software maybe most of you know as Eagle. We have Maxon Motor, SolidWorks. Then we have Solid Line AG, where we have Schneider Kreuznach, MindMeister, and very important, Xilinx, and what I really like is O'Reilly. The folks at O'Reilly are absolutely great, I have to say this. Not just the books, but the folks too, absolutely. Okay, this is my first part. Der Funkempfang ist manchmal nicht da, da musst du einen Tick rüber gehen.
Okay. Hello, my name is Michael, and I will tell you something about the status of our rover development. We will talk about the requirements we need to build a rover. Juergen will tell about the concepts, the rover we have, especially the mass. We will show you something hardware we built in the last year. I will show you some pictures of the technology we use in our rover, and we will take a short view in the future of our rover development. Requirements. First requirements, as Robert said, will be set by the Google Lunar X PRIZE. 500 meters driving and Mooncast. Mooncast, remember, was sending text files, sending a live stream, and so on. We have requirements we set in ourselves. That means 5,000 meters driving and surviving the lunar night. But all of these requirements have to face the moon. The moon sets his own requirements, and the first and most important is temperature. We have minus 160 degrees at night and plus 160 degrees at day. And to find material that handle these temperatures is not so easy as it seems. The surface itself, we have no maps about the surface you can use to set a roadmap for the rover. The rover had to find its own way and had to go it alone. And a really bad thing is regolith. The most part of the surface of the moon is covered in regolith, and regolith is a very, very bad thing. It's very abrasive, and there's a story that the Apollo astronauts have black hands from it. It came into their spacesuits, and so have we to make sure that our electronics, our bearings have really good sealed to save it for regolith. Juergen will say something about the components of the rover and their mass, so you can see how we planned.
Yeah, thanks to you, Michael. It's also from my side a hello to the audience. As a mechanical engineer, I never thought to speak on the CCC. It's a great pleasure for me. But now let's have a look on this side behind me. On this side, we will list the final components of our rover and their planned mass. Let's start with the first point. Is the mobility. The rover is equipped with 4 360 degrees turn-able wheels. Each wheel has one motor for traction and one motor for steering. To further enhance the mobility, each wheel is suspended by an independent passive wheel suspension, and the mass where one wheel include the traction motor won't exceed 250 grams. So 1 kilogram total for all 4 wheels. And the second point, there is the tower. The final version will have a turnable and tilt-able camera tower. By design, this rover we will present you today doesn't have a camera tower. This has 2 reasons. Firstly, the main purpose for the prototype are the driving tests and also the tests of the electronics. And secondly, we have decided on one particular camera model yet. The size of the camera plays a considerable role in the design of such a tower. But the total mass of the tower shall not exceed 1 kilogram. Then we have the control. The main computing unit, or MCU, makes up the entire electronic component of the rover. Its mass includes the tank holding it, shall not exceed 500 grams.